Hello and welcome to our first Python tutorial about rock, paper, scissors. This is going to be done in Trinket. You can go to trinket.io to find Trinket, and this is where you'll get the chance to sign up for an account if you don't have one already. So if you don't have one already, click the big green button, make sure you have a parent to supervise you signing up, and you can create an account with your email and a password, or you can sign in with Google. I don't know what Clever and Edmodo are, but assuming that. But certainly if you have a Google account, and so I know that all of us have Google accounts because we're in Google Classroom, that's a helpful way of connecting your Trinket account to your Google account without having to create and more importantly remember a password. Anyway, that's Trinket. But if you don't have an account, it's no big deal because there's plenty of ways to save without an account, which you can't do in Scratch, so I'll come back to in a minute. So we search Code Club projects to the first result, to the Raspberry Pi site, which has both the Code Club and the Coder Dojo projects. We go to Python Module 1. There's the About Me project, which is a brief introduction, but we're going to go straight into rock, paper, scissors. Now, this is a game of rock, paper, scissors where the player will choose their move, rock, paper, or scissors. So if I pick a letter that doesn't exist, it tells me he doesn't understand, as expected. If I pick rock, it's going to show me, so that's the icon for the rock, the little O, versus that's a flat sheet of paper picked by the computer, so the computer wins. If I pick paper, paper versus paper, that's a draw. So the computer just pick his move at random. So I basically have like one chance out of three of winning, one chance out of three of losing, and one chance out of three of drawing. Now, the stuff we're going to learn here, this is really what's important. We're going to learn about tests, so if, else, else if, and so on, if then else, variables, and boolean operators, so checking that something equals something else, and looking at AND, so if something and something else, so it both needs to be true for this to evaluate as true. It's all part of the Raspberry Pi digital making curriculum, so let's have just a quick look at that to show where it sits. You can see that those basic programming constructs to create simple program control flow statements, so those are conditional, if, then, else, else if, variables and simple data structure, and a variety of logical, arithmetic, and comparison operators. And those are covered by Lost in Space and Ghostbusters that we have already seen, Chatbot that we haven't seen yet, and a couple of Python projects that we haven't done yet. So you can see that this links back to the projects we've seen in Scratch. But let's jump right in. Now, Python is a grown-up programming language. I have made my career in Python, so it's proper. So because of that, this is going to be a grown-up video, in that I'm going to do it all in one long video, and then you can pause if I'm going too fast. So, first page, the player's turn. Let the player choose rock, paper, or scissors. Open this Trinket. Jump to CC RPS Go. This opens it in a new tab. It should look like this. You should just have the hash exclamation mark /bin /python3 from random import rand int. So from the random package, we import a function that picks a random integer. That's what rand int stands for. And there we are. So this is what Trinkets look like. I am logged in. You can see there's a little silhouette. If not, you'll see a little door with an arrow to log in. But don't worry too much about logging in, because even if you're not logged into Trinket, you can, once you've done your project, you can share it, either download it or maybe email it to yourself, so that you'll be able to find your code. It won't be saved against your account, but you'll be able to kind of, save your code and load it up again, which is all that matters. So let's get started. You'll use rand int later to generate random numbers. That's the random integer. Yeah. So we'll just want player equal input bracket, open the bracket, and then the string with the question mark, so what we're asking, close the bracket. And we're going to print out what the player has chosen. So player here is a variable, and we're assigning to that variable the result of this call to the function input. The function input takes a string. String in Python are delimited either by double quotes, which are those double quotes, like little double inverted commas, or by single quotes. So you can use one or the other. It is important that you don't, open the string with a double and close it with a single, because that wouldn't work. You need to kind of close it with the same thing you have. So those are our options: rock, R, paper, P, or scissors. S question mark. Now this is going to print this string of characters and is going to ask for an input from the user, and then going to put the result of that input in the variable player, and then I can print what do we, oh, player versus. So I'm not going to print just player, I'm going to print player and vs. So if you put, so print player will just print, you can print hello, you know, just like that. I run it. So I've picked rock and it prints hello. But if I print player, it's going to pick, is going to return to me the very variable I have chosen. So R is going to print R. But if I put more than one thing in between the brackets of print, it will just concatenate the strings, which means it's going to print them one after the other, separated by spaces. So if you want to do P versus R, or whatever it is, this is quite helpful, because it's going to show, let's say I pick S, see there's a space and versus. So you don't have to kind of, you know, do your sort of complicated string substitution and so on, just kind of put whatever you want, like separated by comma in the print statement, or actually print function call. And there you have it. So that's, yeah, we've done that. Test your code by clicking run. It's asking me if I put K. Now that's the thing, if I can put whatever I want here, right? And it's gonna you know, feed it back to me, because we're not verifying. We're asking for R, P, or S, but we're just like, you know, accepting whatever is returned and putting that into the variable player. So later on, we'll put something to check that our inputs are indeed what we expect them to be. So this is working. Now the computer's term. Now this is quite interesting here. Now, is the computer's term, you can use the rendint function to generate a random number to decide between rock, papers, and scissors. So rendit will generate, so rendit 1, 3 is effectively asking the computer to pick a random integer. An integer is a whole number between 1 and 3, and then we're going to print chosen. So just below that, chosen equal rendint between 1 and 3, and then print chosen. Run this. Oop. Be careful, that happens to me all the time. Once you run it, you need to make sure you click in the console, so the console has the focus. You can see the cursor blinking. That's important, because otherwise I end up, this is why I ended up with VSSS. I end up accidentally typing into my code when I want to be typing on the right side. So S, and in that case it picked 2, and it's returning 2, but it's not always 2 because it's random between 1 and 3. See, I've put in another S here, 1, and so on. 2. Alright, so far so good. Now, so far we've just picked a number between 1 and 3. We've not picked a move, so we need to map this number to a move. We're going to use if, else statements, and we're going to use the value, we're going to check, we're going to do an equality check, the equal against the chosen variable, and depending on the value of the chosen variable, populate a variable called computer with a 1-character move that's going to be R, P, or S. So it looks somewhat like this. Let's leave the print chosen here, I think they, yeah. If chosen equal 1. Now, and don't forget the colon here. Now, chosen equal 1 is different than chosen equal. Chosen equal is pick what is returned by rendint and put it in chosen. It's assigning. That's what we call an assignation. It assigns the variable to whatever value is on the right-hand side. Whereas this is a test of equality. So this is an expression that evaluates to true or false depending on whether chosen is equal to 1 or not. And then you'll notice that when I press return here, by default, there's a tab here, just 2 little spaces. It's not like flush against the left margin. And this is how you would identify blocks of code in Python. Very much like in Scratch, you would have those orange test blocks with if, then, else. Here it's kind of implicit in that you'll be looking at the level of indentation, how far to the left edge of the page the line is, to understand how things are nested into one another. So if it's 1, this is gonna be, well, the first one's rock, and then we go back here, elif. Elif is just else if, right? But elif chosen, so else if chosen is equal to 2, colon again, then we're setting computer to P for paper, and then finally else. So it's if, else if, else. The last one is else. In that case, it's chosen equal 3. Again, a colon. Don't forget the colon. Again, there's an indentation. Don't forget that it's indented correctly. And we're going to set computer to S, the last one. And here, because I can print computer, and because I've aligned this like to the left, it's all the way on the left, it understands that it is outside of this if-else block. So if I run it, it's not bad input on line 16. Yes, it's else. Else doesn't take a test, it's just else. So, oops. Yeah, so chosen equal 1 or else if chosen equal to else. So, I mean, because we've asked for a number between 1 and 3, then if we're here, obviously chosen is equal to 3, and then computer is S. You can comment things out by putting a pound sign or hash at the start. So we're not going to show chosen anymore, but instead we're going to print computer. So here, still asking me, oops, not in the right place, R, and then it's picked, as it happened, 3, which is scissors, and so computer gets set to S. So far, so good. So this is looking exactly like it should. Now, the computer's choice get printed on a new line. Yes. Right? That's the S. Whereas we want the S to be here, R versus S. Right? So you can fix that by adding end equals and then a blank, a space just in between single quotes and middle quotes. So that's a way to saying end with a space, don't end with a new line. So I'm just going to put it's in here, right? Comma, end equals space. And just for my own sanity, I'm going to make it double. I mean, you can use double, you can use single, but I try not to mix them too much. Just so let's have a look at that in action. I'm picking paper. P versus R. Good. Try it again. R. Oh, not in the right place. R. R versus S. So that's all looking pretty good. For now, you'll have to work out who won yourself. Now, let's use the Python code to work this out. All right, check the results. You need to compare the player and computer variables to see who won. So if player equal computer, if the player and the computer have picked the same move, then that's a draw. We can do that and test it. That would be here. So again, it's an if statement. This will need a boolean expression, so something that evaluates to a true or false. So that's a test. Look at the double equal. It's a test. It's not an assignation. And then it ends with a colon to indicate that that's the then, if you will. The colon is like saying, if you were saying then, to say what's coming next is going to come indented from the left, and it's going to be what we do if this condition is true. So we're printing draw. Run this. R versus R, draw. Excellent. Let's just make sure that it doesn't draw every time. R versus P. R versus P. I won. No, the computer won. Yeah, see, we do need to kind of check this stuff. But we've handled the draw, that's correct. Now, let's look at the case where the player chose R, but the computer didn't. So we need to do a elif player equals R and computer equal S. Elif, in this case the player wins, and then elif player equals R and computer equal P. So we'll need to do 6 of those, elif, 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 2 for rock, so elif player, so player aspect rock, and computer aspect, what's the first one? S. That's interesting. We'll have P first, but sure, whatever. Oh, because we're putting the win first, so this player wins. Yeah. Print. Now remember, print brackets and then double quote. Player wins. Elif player equals R and computer equal P. So the players pick the rock, but the computers pick the paper, so the computer wins. Again, we put the colon here, so the next line is automatically indented. Print, open bracket, open double quote. You'll notice that Trinkets automatically closes the double quotes and the bracket because it knows that your things need to be balanced. If you've got mismatched thing, you'll see something looking like that. So for instance here, you can see the draw like that's red, and it shouldn't be because that's just the way the system Trinkets way of telling you that it thinks that this close bracket is part of the string because we've not closed the string separator. Computer wins, exclamation mark, and then we're going to so I'm going to be smart and save myself some additional work by immediately pasting that and just changing it ever so slightly. So the second one is going to be P. If I'm doing paper against rock, I win. If I'm doing paper against scissor, I lose. And here the last one will be scissors against, what's the one that wins? Scissor against the computer's paper, the player wins, and the player is the scissors against the computer's rock. The computer wins. And that should be all, 6 cases. Let's run this. I pick rock versus P. Computer wins because the computer's paper obviously wraps the rock. I mean, this is all looking pretty good. But you got to be pretty careful here because it's very easy to kind of, miss. You put the wrong letter here and there, and you'd have like one of the 6 possible cases actually returning the wrong outcome. So you'll need to make sure that this is all as it should be. You can verify them if the player is the rock, the computer is the scissor, the player wins. The player is the rock, the computer is the paper, the computer wins, and so on. Yeah, so we've done the first one. I've kind of pasted that on the second one. And can you add the code to check for the winner when the player chose S and the computer? Yeah. So this is what it looks like. We asked to pick something, we pick something, then the computer picks something, and we get told what is the what's the outcome. Now, you can stop here if you want, but we've got a couple more challenges. Let's do that, and we're going to do those with tests. So we'd like to have something where instead of kind of showing the letter, we want to see a little bit of ASCII art. ASCII means just text. It stands for character, probably. What does ASCII stand for? American Standard Code for Information Interchange, which is just like alphabet. Really? Yeah. It has to be American for some reason, but it's used elsewhere. All right. So instead of just printing the computer, if chosen equals 1, we're printing... Now, instead of saying print computer, you'll need to add a new line to each of the options in the if to print out the correct ASCII art instead of player. Okay, well, we can do that. So we already have a conditional structure, if, else for chosen that determine the computer. So what we're going to do here, we need our variables to keep the same values. We don't want to put the ASCII art, in that case the O or the 0, in computer because we're testing on the value of computer and player further down in the code. So we can't change what we set into computer, but we can and we will change what we print So there would be an O, no, 0. Is it 0? No, it's capital O. Yeah, capital O. For the paper, it's a couple of underscores, 3 of them probably. Yeah, three underscores. And for the scissors, it's... Now you'll notice that as I press return, that next line comes in at that level of annotation to indicate that, you know, you're only doing those 2 lines, line 16 and 17, if chosen is not equal to 1, that's why we went to the else block, but chosen is equal to 2, this is where we're going into that bit. And for the last one, it's the scissors, which is a greater than and an 8. Is that right? Or B? No, an 8. It's fine. So this takes care of computer. We can remove print computer because we don't want the letter of the computer's move. The printing is going to be handled by this. But what we need to add here before we print player, instead of printing player, we'll want to do an F, same kind of deal. So if player equal R colon print the rock is the capital O, backspace to get back to the first level of annotation, elif player equal P colon print 3 underscore. Oh, and we need to also say end equals a space. I'm just going to take that, copy it, and paste it here, and then elif player equal S, comma print. You can tell I had a typo there. So if I misspell print and print, you can see that it doesn't really recognize it, and it's not, you know, it's not in purple, and it tells me print is not defined. You mean something else. So pay attention to the colors and what it looks like in your trinket, because that is actually useful information, not just pretty colors. And if it's the scissors, we have the symbol for the scissors and the end delimiter. And we don't need to print player because we're just gonna start printing like right at the end of the first symbol, right after, and this should work. What I'm gonna add here, so I've got my 3 cases here, but it is possible to, if there's an else, this means the player has entered something, but what we have in the variable is not an R, not a P, or not an S, which means we don't know what it is, so we're going to print an error. Please pick R, P, or S. Now this is where it's quite practical that Python uses either indifferently either single or double quotes as their delimiters, because that's actually, they show it a little bit in the very first project, the intro, because I can have my string wrapped by double quotes, and within this have like literal quotes that appears as quote as single ones. And I'm going to put, is it an end, error, exit 0? Surely, does that work? Nope. And they've not asked me to do that. Print player needs to add a new if statement to check which item the player chose and print out the correct ASCII art. Yes, indeed, that's fine. So let's save it. If I pick R, yes, so I've got my ASCII art running fine. P, oops, always make sure to put the focus in the right place. So that's player versus my paper versus their rock. I win. Now let's pick something completely different, like completely different. Error, please pick R, P, or S. And because I've put exit, it means it's going to exit here. Now exit, it is, you know, at that level of indentation, so only in that else command, which means we exit the program at this stage. We're not going to go through all of the rest of it, because we don't need to get the computer to pick a move or to check what the outcome has been, you know, from what the result of the game is, because we didn't have a valid input from the player. It's just a little extra bit. And challenge, create a new game. Oh, yeah, fire, logs, water. Yeah, that's kind of quite easy. Well, this one is left as an exercise for the viewer. So do show me your alternate thing. There are some very cool. So general. It's like Spock. So there's rock, paper, scissors. Spock, I think. Oh, lizard Spock. Yeah, right. So it's an extended version of rock, paper, scissors where you have 5 moves, and so you can see that rock beats scissors. Rock also beats the lizard for obvious reasons. Rock is beaten by Spock. I mean, and they are so you can generalize this to any number of. I think they have to be odd. And there's a version with like this is one with 25 different moves, right? Rock, gun, dynamite, nuke, lightning, devil, dragon, Allen. Alien, water, ball, air, moon. They all come with their, and I think there was one with like 107 of them. Yeah, it's a bit. If you play Pokemon, you'll know that the general rules of like what Pokemon characteristics beat what others obeys this kind of logic where each of them, is kind of you're beating half of the other ones and you're being beaten by half of the other ones, and so that makes a very nice thing where nothing is overpowered, and you need to have the right combination to do that. So your challenge can be, of course, like you can change the thing, but to have like, I don't know, cats, dogs, and mice, but you could conceivably extend it to say, to have 5 moves, so you can add lizard and Spock, and so that means that you will need to extend that bit, because suddenly there's a lot more possibilities, because you have like 5 against 5, so that's like 25, except 5 of those are draws, so there's like 20, still 20, 2 or 6. Similarly, you'll need to kind of change those at a couple there, but it is feasible, and it's able to do as an exercise to the viewers, and I look forward to seeing it working next time we meet at the club in person. What's next? Project complete. It was okay. I think I can. Right. That's it for rock, paper, scissors. Don't forget to like, subscribe, put questions, ask comments under the video or under the item if you're watching this in Google Classroom, and I do hope to see you very soon. Bye.